run an executable that will auto-run the whole application, and then walk through a breakdown of how these demos were built. So we start off with just 2D graphics, basic shapes here. So what I'm going to do is build multiple layers here, monochromatic circles, animating basic shapes, and then add blurs to it, create multiple layers of it, and then add a color gradient, and then use the overlay blend mode to get the effect you just saw. So very simple, out-of-the-box effects, which make it easy to have nice visual effects. Next, we move on to the coffee cup, which is a more complex 2D graphics. So that's done first by using a wireframe, which is done just all based on paths. And then you can add shading to it with fills and inner shadows, and of course a little bit of creativity. And then use the circles from the previous demo. You can create a steam effect, make it more fancy. And then say you want to add those particles to get really fancy with this. You first start with Bezier curves that are going to be the basis for a path animation for the particles to traverse. So then that's how that's created. So a lot of it very easy to build with just simple steps because all the APIs are available to you to build with.
Any Java developer can build all this stuff?
Yes.
Okay, let's go a little bit further.
So next we move on here to a multi-touch air hockey game. And this one, even though it looks like it's a static image in the back, it's not. We're using gradients, lots of vector graphics to create this. So
how many nodes are being plotted?
Like thousands of nodes in this one, and then it gets more complicated. So for these kind of, this one has complex groups of nodes, and the scene graph makes it really easy and high performance here, notice that? So the scene graph makes it very easy to attach these nodes to the native multi-touch events using JNI. And notice that the paddle and the puck, these kind of complex shapes, once again, you group basic shapes together using the scene graph and then apply lighting and other things to make it more realistic, like in this case, the edges of the table and so on. This is a very graphics-intensive demo. And for these kind of things, the Prism Graphics hardware-accelerated pipeline really helps us do rendering in real time at 60 frames per second. For these
So it's a combination of what we've done with JavaFX to make it easy for people to build these, but also the optimizations in the JVM and the way we've integrated the graphics engine with the hardware accelerator.
Yes, to give it the high performance. And now moving on from 2D graphics, let's go to 3D and media. So we're starting off by building a video wall. In this case, there's 160 concurrently playing media streams. And notice there's a text box at the bottom. This is a standard control along with a lot of other components in the library. And it can be styled using CSS style sheets. Now, as I type in the text box, you'll notice that it triggers a search on the metadata of the videos. And based on the tag, a bunch of videos fly to form this display shelf effect. It's too bad the camera just moved, but I wanted to show you how responsive it is to touch. Otherwise, you don't really see. So anyway, so I continue to tag the videos. And if you notice, the media wall itself has a curvature on the back. This is once again done by applying 3D transforms to the 2D media views by displaying the videos on the inside of a cylinder. So very compelling effects with just basic, simple, easy to use.
Mix and match Java streams and graphic streams with HTML in this seamless mode between HTML5 and the Java graphics environment.
Yes, and all of this is coming in the next release. So say I want to now play this video. So I can play full screen HD video, and then take the single view and then explode it into multiple views, once again applying 3D transforms to it to form the video wall. Now everything you saw here, like you said, there's 2D, 3D transforms, audio, video, lots going on in the scene with a lot of nodes. Now everything you saw here is dynamic and interactive. Now say I want to make this a more immersive cinematic experience. I can do this by creating the 3D world with a camera that zooms and pans, and also adding physics to the entire scene to provide gravity. So you see the video ball now with all the videos continuing to play on individual views, and it rolls down, and when it hits the video panel, notice that the panel is actually made up of 1,300 cubes. It's not a single view. This scene itself is really complicated. It's made up of 15,000, more than 15,000 nodes in the scene graph. And it has, once again, a rich mix of physics, animations, lots of effects, lots going on in the scene. And I can continue to add explosions and add more nodes to make this even more interactive. And all of this is possible because this is running on the Hotspot virtual machine. And that, along with the hardware-accelerated graphics pipeline, makes it really, there's no performance degradation at all, no matter how much you add to the scene. And a rich set of APIs makes all of this out of the box and easy to use for application developers.
So how many people here in the audience think that's a cool-looking Java UI? So for those of you who are used to Applets and Swing, that's pretty far along. Not only that, our Java client team is committed to delivering this in terms of feature and function in a roadmap for next year. There are two capabilities that I want to talk about. First, the tooling will be delivered through NetBeans. 2 new NetBeans releases are planned in 2011. One thing we're seeing is there's a lot of interest in NetBeans. We've seen a 20% increase in users in the last 6 months. And there's a committed feature list for the next release of NetBeans, including early developer builds available here. Not only that, for JavaFX, all the UI controls and the components, etc., that we're planning to build are going to be available to the developer community in open source this coming year. And the detailed feature function roadmap is available at this URL. So we want everyone we want everyone to know that we want the 9 million Java developers in the world to never have to choose a different environment to build a great looking UI ever again. Now let's move from the client back to the servers and talk about application servers. Java EE 6, which was delivered last year, was a big change for application servers. It addressed a number of issues that we saw in the Java platform for application servers, but there's more to be done. And so where do we see things going? Again, it's back to, we're going to optimize where Java application servers go to enable new application models. There are two aspects to this. First, what we're doing in the application servers around